So equations are things that have equal signs, right? Now we did a couple like easy examples of equations. We kind of went over that if you do something on one side of an equation, like dividing by 2, you have to do it on the other side, right? So that's something you have to do. We talked about different types of equations, like equations that have more than one solution, equations that have no solutions. And then we kind of went through an example, like a very basic example of a linear equation. And we said linear equations are equations where the highest power in x is 1. So you don't see any x squareds, no x cubes. You'll see an x, but there's no power on that x. So it's just x to the first power. And it has this form ax plus b. And you can actually solve it in general and get an answer. You don't have to memorize that answer, but you have to know how to use like the techniques to get to that answer, if that makes sense, okay? So let's just take a look at this example here. This is an example of a linear equation because look at all the x's. They're all x to the first power. And once we simplify it even further, you'll see there's only one x, and that x is raised to the first power. There's a lot of stuff being done. Anyone want to take a guess as to what to do first, Alex? Mm-hmm. Yeah, no, that's perfect. That was even more than what I expected there. That was really good. The first thing that we do want to do is multiply both sides by 2, right? Okay. The reason I decided to multiply both sides by 2 first is, I mean, look at the equation. The scariest part of this equation is that we have division, right? Usually when we have a bunch of stuff being added in like one straight line in an equation, it's pretty easy to solve. But once we add division to it, that's an extra step that I don't really like, that I don't know what to do with it, okay? Now, the goal in each step is to make the equation simpler and simpler and simpler to work with, right? So I think if I multiply by 2 on both sides, well, these 2 cancel out. And now my equation is going to look a little bit simpler. Let me show you what it looks like. Okay. If I multiply one whole side by 2, I'm not just multiplying like the 6x by 2, I'm multiplying the entire thing by 2. So let me just rewrite this using parentheses. 2 times 6x minus 7. Okay. And on the right hand side, I'm left with 2x plus 5 because the 2's canceled out. Okay. So the reason I multiplied by 2 here is because, well, those 2 kind of cancel each other out. Now I'm left with one string of stuff instead of fractions, so I don't have tiers anymore. Okay. All right, now I know Alex kind of said it, but what should I do next? Yeah, distribute the 2, right? Something that's making this complicated is I have a group of terms being multiplied, right? I don't like that. Maybe I should simplify that even more by distributing the 2. So I'm going to take that 2, I'm going to distribute it over to both of them. On the left, I'm left with 12x, right? On the right, I'm left with minus 14. Okay, so I'm left with 2x plus 5. Okay, so that's how I got there. And then just like Alex said, we have to combine like terms. We have an x on the left side, we have an x on the right side. We can actually do multiple things here. We can either subtract off the 12x, or we could subtract off a 2x. Who wants to subtract off the 12? Who wants to subtract off the 2? Okay, both of them are right. I think subtracting off the 2 is easier because if you subtract off the 2, you'll get positive numbers, which is easier to work with. So that's what I like to do. But if you subtracted off the 12, you would not be making a mistake. So let's just go ahead and subtract off the 2x. Okay, and if I'm subtracting 2x from both sides, why don't we just kill 2 birds with 1 stone and add 14 on both sides to get rid of that minus 14, right? So now, if I cross things off, the 2 x's cancel, the negative 14 cancels out, and I'm left with 10x equals 19, right? Okay. So now I'm here. What should my last step be? Divide by 10, perfect. And once I'm here, I get x equals 19 over 10. And that is my solution. Okay. Any questions on example number 1? Yeah. Yeah, I do. Alex, what was your question? Yeah, so for my class, I will say A lot of you will want to like write this as a decimal. Decimals in this class are just kind of discouraged. In some decimals, if you get an exact decimal, it's like fine. But especially if you get one of those decimals that repeat forever or that have like a really long decimal part, it's just easier to do a fraction because that's like an exact number instead of like an approximation. Yeah. All right, good question. Any other questions on example one? Yeah.
Yes, we're getting those two on each side. What they come from.
So when we got these two?
No, where it's not the two on each side.
Oh, the two on each side? Oh, very, very top, right? So that's kind of like my first step, right? So when I saw this, I was like, the most complicated thing to me is that there's a two on the bottom, right? There's division. I don't really like dividing polynomials. I just like adding and subtracting and things like that. So what we did is we decided to multiply two on both sides. And what that does is it canceled out the twos on the right. So we got this. And that looks a lot simpler than a fraction, right? So what we're left with on the left is if we do it on one side, we have to do it on the other, which is why I have a two on the left there. Does that make sense? Cool. All right, I'm gonna put you to the test. If you flip the page over to example 2, I have another example. Okay, this is an example of another linear equation. You might not see it at first. It doesn't look linear, but it does turn into something that's linear. To the front here, I was looking at some good work as I was walking around. Let's just go over this one real quick. All right, so I think that's Liam. I'm not sure if that's his name, but all right. Now Liam kind of got out of it, but that's okay. I'll explain his steps. Okay. Now the first thing we did here was FOIL, right, or distribute out. Kind of like what we did on the quiz last week when we multiplied two polynomials. So we did it on the left-hand side and on the right-hand side to get to this step, okay? Now, once we're here, I think what Liam did is he saw that there were two like x's next to each other. So he just added those x's together to get the 26x and the 14x. So now there's like 1x squared, 1x, and one number in each of the sides of the equation, okay? Once we're here, I think he added the 8 on both sides of the equation. So now we don't have a number on the left-hand side, but we do have a 5 on the right-hand side, okay? Once we're here, we notice that, okay, there's two 24x squareds, right? There's one on the left, there's one on the right. You can either just subtract 24x squared on both sides, or you can just cross them out, right? So we're left with 26x on the left, 14x plus 5 on the right. Now here we have to combine our x's now, right? We can't just like add and subtract or divide or whatever to get x. We need to combine all the x's together. So that's why we subtracted 14x on both sides of the equation. So now we have this equation. Once we're here, we can just divide 12 on both sides to get our final answer. You should have gotten 5 over 12. All right. Any questions on example number 2? Okay, I'm going to put something similar to this on the quiz, also on the quiz review. So definitely take a look at this. All right, let's make this a little bit harder. All right, if this wasn't hard enough, we are going to talk about something a little bit harder. Let's take a look at this equation here, okay? Now this one, it looks very similar to the first example we did in this class where there's like a 2 on the bottom. We had to multiply out the 2 first. This is an example of, it's not actually linear, okay? This is an example of something called let me actually move this, a rational equation. Okay, and the reason this is rational, the word rational in math usually means a fraction, okay? And it's not just a fraction that makes this rational. If you take a look at the denominators in here, there's x's in the denominators, okay? So something's rational when there are like x values in that denominator, and you have to work to get the x's out of the denominator, okay? That's when we have to deal with rational stuff, okay? Now what I'm gonna do is I'm actually gonna show you how to solve this. I'm not gonna explain my thought process fully, so it might be confusing as I go through this, but I just wanna show you what it looks like to solve it. And then we'll talk about like a step-by-step approach on how to solve it a little bit later, okay? So kind of like what we did on example 1, where we multiplied 2 on both sides to get rid of that 2. Well, I see that there's an x minus 2 in the denominator, so why don't I just multiply both sides by x minus 2, right? So I'm going to take the right-hand side, multiply it by x minus 2. Okay, I'm also going to do it on the right hand side and multiply that by x minus 2. Okay, now once we're here, it's a little bit tricky because we have a bunch of stuff being multiplied, not just like numbers and letters and things like that. Okay, this is how you go about multiplying these two together. Okay, on the left hand side, I'm just going to take that x minus 2 and move it into the fraction, right? When you multiply things as a fraction, you can kind of combine it so that I have 3x times x minus 2 over x minus 2. Okay, so does everyone kind of see how I got from the left hand side up top to what I have here? It does. A lot of people do kind of skip steps and cancel these out. If that makes sense to you, go ahead and do it. But in this class, especially when we start making these a little bit more complicated, I like systematic ways to do everything. So like every single question has the same method. If you want to go ahead and do this if it makes sense to you, but just for now, we're gonna do this step. Yeah. Okay. Then on the right hand side, we're gonna do the same thing, but since we have things being added inside the parentheses, we actually have to move that x minus 2 into both of these guys. Okay. So if I multiply the x minus 2 by the 1, I get 1 times x minus 2, right? Yeah. I kind of do it this way because sometimes it gets really confusing when we're multiplying it by more than one thing. I'm going to show this step, but if you don't want to do the one, that's fine. Okay. And the next one, I have 6x minus 2 over x minus 2. Okay. Once we are here, what can we do to simplify this a little bit more? Cancel out, right? I have an x minus 2 on top and an x minus 2 on bottom. So I can cancel those out, right? I can do the same thing on the right-hand side. And I guess I can really just take away that 1 because who needs to write a 1, right? Okay. Yeah, except I do sometimes. Okay. So once we're here, we are left with a 3x, okay, equals x minus 2 plus 6. Right? That simplified it a lot, right? Bless you. Okay. So, what can we do next? Yeah, was that what you were gonna say? All right, negative 2 plus 6, 3x. Oh, plus 4. And then what can I do to even make this simpler? I would say subtract the x. Right now, if you divide, then you might get a fraction, right? Because if I divide by 3, then that kind of just puts the x plus 4 on top over the 3. So I like to combine like terms first. So let's subtract the x on both sides. We have 2x on the left-hand side. We have 4 on the right-hand side. Okay. Now let's divide by 2, right? That's the next step, and we get x equals 2. Okay. So who thinks we're done? Huh, interesting. Who thinks this is the right answer? It's not the right answer. Okay. No, I did. I wrote this down with intent. You will need to know how to do this process. Yeah, right. So for those of you who don't see it yet, how do we know how to check to see if our answer is right? Plug it in. Okay, so let's go ahead and plug in our answer. Okay, yeah, we got 3 times 2 over 2 minus 2 equals 1 plus 6 over 2 minus 2. 3 times 2 is 6, 2 minus 2 is 0, 1 plus 6 over 0. Can I divide by 0? No, right? And if you ever get confused, try doing 6 over 0 in your calculator. It will not like you. It will give you an error. Is 2 a solution? No, right? Solutions are things that you plug into the equation and you get something that makes sense and is an equality, right? This, if I plug it in, it doesn't make sense. It's not equal, right? That doesn't even make any sense. So 2 is actually not a solution, okay? Yeah, this is an example of something that has no solutions. Okay. Now, sometimes you'll do this process and you will get solutions that work. Sometimes, sometimes you'll do this and you'll get no solutions. Sometimes you'll get two solutions and one of them works and one of them does not work. Okay. So basically, when you see these rational expressions, remember rationals are when we have x in the denominator, you still have to solve it. Okay. Because sometimes when you solve it, you get something that is a solution. Okay. But once you solve it, you have to make sure that your answer makes sense by plugging it in. If you plug it in and you get zero in the denominator, it's not a solution. And then you have to kind of wonder about your life. Yes. Yeah.
So there could be possibly two numbers you get. How would
We'll talk about that when we get into quadratic expressions. I don't think this homework has two solutions. Yeah. Yeah, but this would be something that has no solutions. I think there's like a little option on the homework to click saying like, oh, this has no solutions. Yeah. Okay. Well, this is a rational equation. Rational equations are different because you have to make sure that your answer makes sense. Because sometimes it'll make sense, sometimes it doesn't make sense. All right. Let's go ahead and I'm actually going to show you like the process that I did. I know I didn't explain like every step in detail as to like what I was doing. These questions actually like have a very systematic way of going about doing them. So I'm going to go ahead and lead you through that systematic way. But before you do that, I kind of want to explain to you this term that will come about a lot in this class. When we have to deal with things involving fractions. So we're not actually going to do some examples first. First, I want to show you how to think about your solution, and then we'll talk about how to actually do them, okay? So in this example, I have two fractions, and I just want to think about what we're going to do when we add these fractions together, okay? When you add fractions together, the first thing you have to do is find something. I don't know if you remember what it's called. Common denominator, right? So common denominator. And it's basically what the denominators have in common, right? We're not just going to find the common denominator, we're going to find the least common denominator, especially in this questions because they make the, if you don't find the least common denominators in these examples, they get really complicated really fast, okay? So we're going to find the least common denominator or the LCD. Okay. What is the least common denominator in this example? 30, right? Because 6 times 5 is 30. So you would just put each of them over 30. What's 2/5 as a fraction over 30? Is it? Yeah, 12. Sorry, I don't know why that took my brain a while to process, but yes. And I guess 1/6 is 5/30ths, right? Okay. Now that they have the same denominator, you can add them together and we get 17 over 30. Okay. Now, we are actually going to deal with least common denominators in this class. But instead of like numbers, we're going to start adding variables into it. And then it gets a little bit more complicated. Okay. But before we go into the next example, I have another example of fractions that I want to show you. Let's say we did 2 over 10 plus 1 over 6. What would the LCD be here? 60 is a common denominator, but it's not the least. It's actually 30, okay? And the reason it's 30 is let's just take a look at each of these denominators. 10 is 2 times 5, right? 6 is 2 times 3, okay? So what we're gonna do to find the least common denominator is you're gonna take like the 2, the 5, the 3, but I'm not gonna account for the 2 because I already accounted for it with the 10, okay? So 2 times 5 times 3 is 30, okay? I don't need to multiply that 2 in my LCD, okay? Yeah. Yeah, that's where the tree comes along, yeah.
Is that basically like you just simply multiply all the answers to get?
So for example, let me just show you. What if we had a denominator that was 100 and then another denominator that was, I don't know, 60?
Okay.
Actually, let's do 90 and 60.
All right.
Okay. Well, we can do the tree thing where 90 is divisible by what? 9 and 10. Okay. What's 9 divisible by? 3 and 3. And what's 10 divisible by? 2 and 5. Okay. Same thing for 60. So 6 is divisible by 6 and 10. 6 is divisible by 2 and 3, and then 2 and 5, okay? If I were to find the least common denominator, I would go and account everything that I have here. So I've got a 2, but I'm not gonna account for a 2 here because I already highlighted a 2 on the left, right? I would account for a 5, but I'm not gonna account for this 5 now because I already accounted for a 5 on the left, right? I would include, let's see, I would include this 3, but I'm not gonna count this 3, okay? I am gonna count for this 3 because I have it repeated, right? And I didn't underline it on the right. And then I'm also gonna account this 2 because I didn't do that either. So then you'd multiply those guys together and that would be your LCD. Yeah.
Says you can, so the way it works is like you find, you cancel out, you have
Yeah.
both sides, and then.
Yeah, and then you kind of combine everything together at the end.
I know I'm gonna have to. Do that.
Now, we're not gonna do crazy fraction stuff right now, so like we're not gonna do something like this, but we're gonna do something really similar to it. It's gonna be a little bit easier in the variable example, okay? So I know this is kind of confusing right now. Just bear with me until we get to doing an actual example for this class, and then it'll make more sense. Okay, let's do LCDs for this example, okay? Here we have a bunch of stuff. We have x plus 5 in the denominator. We also have x minus 3. If those were just numbers and I were trying to find the least common denominator, I would pretty much just multiply them together if they didn't have anything in common, right? Now, x plus 5 and x minus 3, those are two different things. So let me just show you what the LCD looks like. And it might look confusing at first, but once you start doing more examples, it makes a little bit more sense, okay? The LCD is x plus 5 times x minus 3, okay? That's literally it, okay? I know it looks weird because it's not a number, but it's the LCD because it's x plus 5, x plus 3 is different than x plus 5, so those two multiplied are my LCD, okay?
Will that be the case for anything with an X in it?
It
Like,
gets a
let's
little
say
more,
it's X plus 5, X plus 25.
yeah, then that would be,
Will you just multiply the 5 with 25 or?
no. So we'll talk about when you combine them together. But if 3 was 25, it would still be, you would just replace 3 by 25 in the answer too. Yeah. Okay. Now, what answers cannot be solutions to this equation? -5 and 3, right? Because if I plugged in -5 into this equation, well, the first fraction would be over 0, right? And if I plugged in 3 in this equation, the second fraction would be over 0, right? So -5 and 3 definitely cannot be solutions to our equation. If you don't see it, like just by looking at it, I know like when I first started learning about math, like I would see that and I'd be like, well, how do I find out what I plug in? A trick to doing this is to take your LCD, take each part of it and set them equal to 0. So x plus 5 equals 0 and x minus 3 equal to 0. Okay. Once you do this, you can solve. You can subtract 5 on both sides to get x equals -5. You can add 3 on both sides and get x equals +3. And those are the things that cannot be solutions. So if you solve this equation and you get either -5 or 3, those are not the answer. Okay. All right. Any questions so far? Now, I know this is kind of tricky. I promise you this does get a lot easier. Let's just start the next example and then I'll show you some other things on Friday, okay? Now, here's where we start combining stuff, okay? Now we have a bunch of stuff in the LCD. I'm never going to give you something this complicated on a test or quiz, but finding the LCD, of course, is a different story. Let's see. We have stuff in the denominator, right? We have an x plus 5, so that goes in the LCD. We have a 2, so that goes in the LCD, okay? We have 2 again. Should I write 2 again? No, right? So if I already wrote 2 and 2 is underneath another thing, that doesn't go in the LCD. I'm just gonna ignore that, okay? X minus 2, I didn't write that down, so I'm gonna write x minus 2. I didn't write x plus 25, so that also goes in the LCD, okay? So basically everything that doesn't get repeated goes in the LCD. Okay. All right. If I were to find out which one of these cannot be solutions, I'm going to take each component in my equation and set them equal to 0. So I'm going to take 2 and set it equal to 0. I'm going to take x plus 5 and set that equal to 0. I'm going to take x minus 2, set that equal to 0. x plus 25, set that equal to 0. Okay. Now, if I try to solve 2 equals 0, are there even any solutions to that? No, so I'm just gonna kind of X that out, okay? I can subtract 5 on both sides to get x equals -5. Adding 2 on both sides gives me x equals 2. Subtracting 25 on both sides gives me -25. So it looks like the things that cannot be solutions to this equation are -5, 2, and -25. If you get those as your answer, that can't be the answer, okay? Does that kind of make sense? Cool. All right. Now, I will say, we're just doing the LCD right now. I know I did crazy math when I showed you that first example. We will have a very systematic way to solve this. So if you're like confused when you see this right now, just wait until Friday and you'll kind of understand the process that we do to do this. But right now, as long as you understand like this sort of LCD problem, we'll get a little bit more complicated later on. But yeah. All right. Any questions so far?
I got confused on the first part.
Mm-hmm.
How you cross out the two there.
Yeah, it's kind of weird, right? You know how in this example, 10 is 2 times 5 and 6 is 2 times 3. The LCD, I only counted the 2 once, right? Because if the 2 is underneath here, I could count it, but now it won't be the least common denominator. The same thing happens here, right? There's a 2 here, there's another 2 here, but I'm not going to count that 2 because I already accounted for it over here. Does that make sense?
So you cross out that two.
So in the LCD, 2 only appears once, and it's not going to be like 4. Does that make sense? No, it doesn't get canceled out in the original equation, so I'm not going to cross it out in the question. But my LCD is only going to have one of those 2s, if that makes sense. Yeah, so like I'm not crossing it out of the question. I'm just like I'm making a note to myself not to write it again. Yeah. Any other questions on LCDs? Yeah, so if you get -5, 2, or -25 when you solve this equation, it'll be basically no solution for now. We'll talk about later on when we can get 1, 2, maybe even 3 solutions. Yeah. All right. Why don't we prepare for the quiz?